Good morning. Today's lesson is about the power rule for exponents. Let me go ahead and highlight the power rule for you. Here it is in pink. This is if you have an exponential expression in parentheses with another exponent on the outside, that allows you to multiply the exponents. And I want to show you why that'll work with a specific example. So let's go up here into the blue section and take a look at this example, x to the fifth squared, which I hope you realize means x to the fifth times itself. And since we already know a rule to help us simplify that, that was our product rule yesterday, that is x to the 5 plus 5 power, which is the same as 5 times 2, which gives us x to the 10th power. Let's go ahead and do a few examples. These examples go along with page 436 in your textbook, numbers 10 through 21. So when we finish this slide, feel free to go ahead and work on those. I wrote our rule, which is our power rule, at the bottom of the screen. You can see it right here. And what we're going to do is use this rule to simplify some expressions. So go up to A. We have n to the fourth raised to the 7th power, and this is going to equal n to the 4 times 7 power, which gives us n to the 28th power. If we go to example B, it has fractions as exponent, but it still works the same way. So this is going to be x to the 2/3 times 1/2. And you can go ahead and cancel while you multiply your fractions, and that's going to give us x to the 1/3 power. In example C, we're going to make this p to the 5 times 4 power, which gives us p to the 20th power. Look at D. D just has those exponents in a different order, and notice what's going to happen here. This is p to the 4 times 5 power, which is p to the 20th power as well. And lastly, let's go to E. So this is going to be p to the 1/2 times 1/4. Great opportunity to see if you remember how to multiply fractions. Multiply across the top and across the bottom. This is going to be p to the 1/8 power. This slide also goes along with page 436, numbers 10 through 21, but I've written two rules on the bottom of the page. One is our power rule that we are just learning today, and the other one is the product rule that we learned yesterday. And the reason is we're going to need both of these. And if you look at example A, you're probably trying to decide, what do you do first? If you have both of these rules in the same problem, you want to go ahead and you want to use your power rule first. So when I go to this particular example in example A, I'm going to leave my y to the 3rd alone. And I'm going to work on my power rule right here. So I have 5/2 times -2. Now 5/2 times -2, you can make this a -2/1. When I multiply these, I'm going to cancel those exponents. This becomes y to the -5 power. So I've got y to the -5 power. Now I can go to the product rule that I learned yesterday. This becomes y, whoops, not minus, let's get rid of that, to the 3 plus -5 power, which gives us y to the -2 power, which, remember, this needs to go down below the denominator, gives us 1 over y squared. Let's go to example B here. And again, what we're going to do, power rule first. So we're going to start x squared, we're just going to leave that alone, put a little dot, times x to the 6 times -4 power. So this is x squared times x to the -24 power. Now use that product rule. So this is x to the 2 plus -24 power, which gives us x to the -22 power. Once again, don't want to leave a negative exponent. This becomes 1 over x to the 22 power. Let's go ahead and go down here to example C. Same thing. We want to work our power rule first. If it helps you with the fractions, put a 1 under that 3. When you multiply those particular fractions, notice your little 3's are going to cancel out, and it's going to give you w to the 5th power. So bring over your w to the -2 power. This becomes w to the 5th power. Now we're going to use our product rule, so this will be w to the -2 plus 5 power, which is w to the 3rd power. Now, in my last example, example D, we just have things in a different order. But once again, you're going to use your power rule first. So first thing I'm going to do is use my power rule and multiply those powers. If it helps, put a 1 under that 5. So this is S. Negative times negative gives me positive. So this is S to the 5/2 power when I multiply those fractions times S to the 3/2 power. Now I'm going to use my product rule. This will give me S to the 5/2 plus 3/2 power, which gives me S to the 8/2 power. Remember, keep your common denominator. 8 divided by 2 is 4, so this is S to the 4th power. In this particular slide, we're going to learn a new rule, and that is this rule that I'm highlighting for you right here. I have two numbers multiplied in the parentheses. Raised to a power on the outside of the parentheses means that power applies to everything inside the parentheses. Now, sometimes I'm going to need to use that in conjunction with this rule right here, which is our power rule that we are learning at the bottom of the page. And let's go ahead and go through a couple of examples. So right here in example A, what I'm going to need to do, this becomes 4 to the 3rd, and this becomes m to the 1/2 to the 3rd. Now you're going to find as you get good at this, you're not going to write out this particular step. You're just going to multiply that 1/2 and that 3 right away. So here's what I've got. 4 to the 3rd power equals 64. So 64 m, and I'm going to multiply 1/2 times 3 because I am using my right here power rule, and this is going to give me 64 m to the 3/2 power. If we go to example B, here's how that's going to look. This is going to be 5 squared, and now we have x cubed, and that's going to be squared. We know using our product or our power rule that we're going to multiply the 3 times the 2. So this 5 squared is 25 x to the 6th power. Let's go to example C and let's see if we can power through this problem. So 7 to the 3rd power, gonna need a calculator there, and m to the 9 times 3 power. And so let me grab the calculator. 7 to the 3rd gives us 343. M to the 27th. Now, this is really interesting. If we go to example D, I want to show you a neat little trick with this. And if we go back, remember this particular rule right here? A to the negative n equals 1 over a to the positive n. In this case, we have a negative exponent on the outside. Here's what I want to do with this. Let's take this and we're going to do 1 over 2z to the positive 4 power. Notice I've just used this rule right here. And now I'm going to do the same thing I've been doing, but everything's in the denominator. So 1 over 2 to the 4th, z to the 4th. And 2 to the 4th is 16, so 1 over 16z to the 4th. All right? Last one here. I'm going to do this one kind of a wonky way because I think a lot of you are going to get yourselves in this predicament and then you're not going to know what to do. So I'm going to go ahead and I'm just going to use my rules, and I'm not going to use this rule right here, but I'm instead going to give myself 3 to the negative 2 power, which already is probably freaking people out. And then I'm going to have g to the 4 times negative 2 power, which gives me 3 to the negative 2 power. And you are probably already going, what in the world is that? And then I have g to the negative 8 power. Here's what that is. Move it to the other side of the fraction bar. So this becomes 1 over 3 squared g to the 8th, and we need a little bit more room down here, so 1 over 9 g to the 8th. Okay, these are probably the most complicated examples we're going to do today. We're nearing the end here. I did write down for you at the bottom of the page, this goes with page 437, numbers 22 through 33. Also, I wrote in pink here a couple of our most important rules, our product rule and our power rule. And let's go ahead. Remember what we said. If we have both of these, we want to do our power rule first. So when we tackle these, I'm going to do this and this using my power rule, and then I'll use my product rule to put them together. So this is going to be x to the negative 2 times 2 power. And that's going to give me x to the negative 4 power. Then I'm going to have 3 to the 4th, x to the 4th, and y to the 5 times 4 power, which gives us y to the 20th power. All right, and it's really important that we understand that we need to do the power rule first. So I'm just going to simplify my 3 to the 4th. That's going to give me 81. So this is x to the negative 4th times 81 x to the 4th y to the 20th. Now what I'm going to do is use my product rule, and I'm going to use my product rule for these x's. And that's going to give me, when I add those exponents, x to the negative 4 plus 4 power, which is x to the 0th power, and anything to the 0 power equals 1. So that is just strictly gone, and all we're left with here is 81 y to the 20th power. So let's go ahead and do example B. All right, so I have 6 to the 3rd, great, gonna need that calculator again, a to the 3rd, b to the 3rd, and we're multiplying that by 5 squared, and a to the negative 3 times 2 power, which is negative 6 power. So let's get out the calculator for the 6 to the 3rd power, which is 216. Now, I've got a to the 3rd, b to the 3rd times 25 a to the negative 6. Now, what I can do is just multiply the 216 times the 25, and that gives me 5,400. I know it's a big number here. They're just coefficients. We're just going to multiply them. With the a's, we're going to add those exponents. So I'm going to add the 3, you see that right here, with the negative 6. And when I do that, that's going to give me the negative 3 power. So I'm going to have a to the negative 3rd and then b to the positive 3rd. The last thing that I do need to do with that, I can't have negative exponents in a final answer. I need to move that below my fraction bar. Everything else stays on top. So I have 5,400 b to the 3rd power over a to the 3rd power. I'll do one more example here for you, just so you have another one to look at before you tackle your homework. And so we're going to go ahead and do our power rules first, and then we'll do our product rule. So this is going to give me 3 to the 4th. This is going to give me c to the 5 halves times 4, and if it helps you, put a 1 under that 4. So 5 halves times 4, multiply your numerators and denominators. Look at it. It'll give you 20 over 2, right? 20 over 2 is 10. Over here, this is c to the 2 times 3 equals 6 power. So this is going to give us 3 to the 4th is 81, c to the 10th times c to the 6th. Now we're going to use that product rule and add those exponents on the c's, and this will give us 81 c to the 16th power. Lastly, I'm going to show you how to apply what we're learning to working with scientific notation, which you're going to need for your high school science classes. So let's go ahead and look at this number written in scientific notation, and it is raised to the second power. So here's how that's going to work. Using the rules that we already learned, this would be 3 squared times 10 to the 8th power squared. So this is 9 times 10 to the 8 times 2 gives us 16th power.